I'm with Yuzhny Design Office of Ukraine as a director of the European representations in Brussels. And also I'm with MVA, Moon Village Association, member of the board of directors in charge of the Moon Market Development Coordination. It is in this second capacity that I'm very pleased to co-chair our today's event. But let me start by saying kudos to the US and Japanese colleagues who performed a successful return of the Orion mission and the Hakuta R launch respectively. We keep fingers crossed for the successful continuation of the Hakuta R mission. As you may know, Moon Village Association is a unique non-governmental organization based in Vienna, Austria, and acting as a permanent global informal forum for stakeholders like governments, industry, academia, and the public interested in the development of the Moon Village. Our aim is to facilitate and to foster the creation of the Moon Village, and we at MVA believe that involvement of the non-space industries in the moon exploration and utilization can bring an important added value. That is why 2 years ago, we launched a series of webinars called Non-Space Business Goes to the Moon. After the first webinar, co-organized with the European Space Agency, and the second one on space resources, conducted together with the Luxembourg Space Agency, for our today's, the third event, we have united forces with JAXA, Japan Aerospace Exploration Agency. Our intention is to showcase, this time, the automobile industry's capabilities and opportunities of cooperation with space industry. We hope it will be especially beneficial to both sides after the MVA has disclosed Urbi et Orbi at its annual workshop and symposium last month, the Lunar Commerce Portfolio, a unique product by MVA Lunar Commerce and Economics Working Group, and the definitive authority source for lunar commerce opportunities. Now it is available on the MVA website and everyone can get acquainted with the document. At the same time, we all know that JAXA is one of the world leaders in what concerns automobile industry's engagement in the moon-related activities. Together, we have prepared for you an excellent lineup of speakers from Japan and North America, which are going to be presented shortly. But now it gives me a great pleasure to introduce Naoki Sato, Director, Space Exploration System Technology Unit, JAXA Space Exploration Center. Naoki-san, please. Do we have Naoki-san? While Naoki-san is somewhere around and about to join us, let me tell you that we have structured our event in the following way. There will be two parts. Naoki, are you here?
Yes, I'm here, but can you hear me?
Yes, now it's perfect. Please, the floor is yours.
Okay, sorry for that, but again, I'm Naoki Sato, JAXA, Director for the System Technology Unit at the JAXA Space Exploration Center. I'm very pleased to be the co-chair of this webinar, and I'd like to share some presentation from me. So, can you see my chart?
Yes.
Okay. So, so JAXA is now researching on the pressurized rover on the moon very heavily. But this is just a kind of start for the humankind. So I believe that we are going to enter into the new decades for the new moon activities, which will be based on the many mobilities. So I would like to talk about the two topics. For the number one is how designing the smart lunar rover in the decades to come, and also the what kind of infrastructure to be is needed to support such kind of lunar mobility. These are the two topics for today. And I also want to share the current international movement for the lunar exploration. So I'm also a member of the International Space Exploration Coordination Group called ISEC-G. And recently, we have issued the Global Exploration Roadmap, GR Supplement 2022, and which is including the growing global momentum and also the major updates in the lunar exploration plans and the lunar surface exploration objectives and updated lunar surface exploration, and increasing the industry capabilities and also the scientific priority enabled by exploration. So if you're interested in this document, please access to the links that below. And sorry, it's not shown the actual roadmap. Sorry, my mistake. But anyway, our future vision is shown here. So after the demonstration of the technology by space agency, we are envisioning the fully development lunar economy as shown here, as you can see here. So for the fully developed lunar economy decades, there should be many mobilities in the lunar orbit. But so in this webinar, we'd like to talk the what kind of the smart mobility will be there, and also what kind of infrastructure should be needed in the decades to come. So thank you very much for attending.
Thank you very much, Naoki-san. So you have seen what is going to be a structure of our event, and I suggest that now we introduce the participants. I start with Mitsubishi Heavy Industries, MHI company. We have with us around this virtual roundtable, Hiroaki Kodama.
Good afternoon, everyone. My name is Hiroaki Kodama from MHI. Thank you for inviting me for this webinar today.
Great, thanks a lot,
yes.
Hiroaki-san. We have Junichi Yamaguchi from Toyota Motor Corporation.
Good afternoon and good evening, everyone. Thank you for inviting me.
Thank you very much, Junichi-san. From Lockheed Martin, we have Derek Hodgins. Hello, Derek.
Hello. I'd say I'm a man of few words. Derek Hodges, I lead commercial civil space strategy at Lockheed Martin.
Okay, good. Thank you. We have a representative of the MDA company, Faizan Rematullah.
I am Faizan Rematullah from MDA.
Good. Thank you very much, Faizan, for being with us. And we have Lunar Outpost company, Justin Cyrus.
Great to be here this morning. Thank you all.
My pleasure. So with that, let us move to the first subject of our today's event, which is designing a smart lunar vehicle. And each of the participants gets 5 minutes for the respective presentations. After that, we will have a roundtable discussion on some questions that we have accumulated from some colleagues interested in this particular topic. So let us start with MHI, and I pass the floor to Hiroaki Kodama. Please, Hiroaki.
Okay. Today, I will introduce our contribution to lunar mobility, especially to the pressurized rover, working with JAXA and Toyota. I'm Hiroaki Kodama, in charge of the engineering management and involved in the development of lunar polar exploration rover. At the beginning, I would like to briefly introduce our company's activity of space development to you. I suppose that we are known to everyone as a company which provides a transportation system as typified by H2A or H3 rocket, and also HTV. On the other hand, we also underwent the development and its operation of ISS Kibo module for the past decades. Through this experiment for the crew life support, such as the thermal and environment control system, we are now participating in the Gateway program based on these experiences. And furthermore, we are going to develop the lunar exploration rover for upcoming mission. I will be our first field. It will be our first field and will be the big turning point for our company's business. We believe that these activities and experiences will contribute to the development of the lunar pressurized rover, which will be used for lunar exploration. Today, I will explain the LUPEX project. This is my project, and LUPEX is the abbreviation for Lunar Polar Exploration. It is an international joint mission of JAXA and ISRO, which is Indian Space Agency. JAXA is responsible for the development of the rover system and procurement of the launch vehicle, H3. And ISRO is responsible to develop the lander system. The mission objective can be divided into three. First is water prospecting and analysis on site. And the second is acquire the environmental data. And the last one is the most related objective to today's topic, demonstrates the mobile capability at night survival. The landing site is South Pole, and the mission duration is about 3.5 months after landing. The launch date will be the middle of 2020s. This is a conceptual drawing of the rover. Total mass is about 350 kilograms and within 2 cubic meters in volume, except for the solar array panel. The 4 crawlers with independent steering are equipped for running function. This system is not desirable from the viewpoint of weight. However, it will bring a big advantage for running on the rough terrain. And the power system consists of solar panel and lithium-ion batteries. to obtain sunlight in polar region. The solar array panel will be installed as high as possible. The rover system accommodates 7 payloads. Each payload is developed for the purpose of the water prospection. We consider that there are 4 key technologies of the rover system, which will contribute to development of the lunar mobility. First, thermal control. In the polar region, the condition of sunlight strongly depends on the undulations of the ground. Therefore, the temperature of the environment will change dynamically as the rover running. To control the temperature of the electronics within the moderate range, highly advanced thermal control devices are required. And second is navigation. The rover system has a navigation camera with LED light and other sensors such as IMU, star tracker, sun sensors to identify the amount of the rover movement and the direction. It is assumed that there are few landmarks and high contrast visual environment on lunar polar surface. The environment will make the navigation difficult. However, it will contribute to develop the better navigation systems if we obtain the data through the mission. And mobility. Regarding to the mobility, it is expected that some important data, such as sink, slip, or surface friction, will be obtained. This data will be very useful to design the optimal mobile system in the next mission. And more, the rover system has a drilling system to collect the samples from subsurface. Drilling will tell us the information of the mechanical properties of surface and subsurface soil. As stated here, we believe that our first mobile exploration in polar region will contribute to the lunar mobility. This is all for my presentation for topic 1. Thank you.
Thank you so much, Hiroaki-san. Now I give the floor to the representatives of the Toyota Motor Corporation, Junichi Yamaguchi. Junichi-san, the floor is yours.
Yes. Can you see the PowerPoint? Is that?
Not yet.
I've shared, but can't you see?
Not the picture did not appear yet. We can see you perfectly well.
Sorry, then I share.
Now it's in place. Thank you so much.
Can you see?
Yes.
Yeah, thank you very much. Good afternoon and good evening. My name is Junichi Yamaguchi of Toyota Motor Corporation, responsible for Pressurized Rover joint research together with JAXA. Today, I'm very happy to have a chance to join this MVA Association webinar. As you may know, Toyota Motor Corporation is an automobile company, not a space company. And of course, do not have any experience of space development. We started joint research of pressurized rover since 2019. It takes only about 3 years, and I was in charge of automobile design till 2021. It is only 1 year and 4 months since I started to research pressurized rover. This time, the theme is moon surface mobility, and I am familiar with ground vehicle technology. Then I will explain such a viewpoint. First one is designing smart lunar vehicle. This is a picture shown a pressurized rover together with JAXA. Just a moment. This is a pressurized rover. Size is about 6 times 5.2 times 3.8 meter with habitable volume 13 square cubic meter with 2 crews. As a mission, total 10,000 driving range and 1,000 driving range by O2 and oxygen, hydrogen and oxygen charge. This is running with fuel cell system and autonomous for crew safe move. This is a schematic diagram comparison between the lithium-ion battery and the fuel cell system as a viewpoint of weight and size. For both weight and size, fuel cell system is lighter than lithium-ion battery, and the space is smaller than lithium-ion battery. This is a rough study for 1,000 driving for pressurized rover. So fuel cell system has a much merit to run in the lunar surface for pressurized rover. The point of view, ground technology to the moon mobility. To implement fuel cell for pressurized rover, we are going to apply ground technology to space. Toyota is selling a fuel cell vehicle called Mirai since 2014. This picture shows second generation Mirai that is sold at Japan, EU, and North America, and so on. This Mirai has a second generation fuel cell system, which enables 850 kilometer with WLTC mode on the ground, which has lightweight as E-segment electric sedan. Using these ground technologies such as fuel cell and storage tank, Toyota is researching together with JAXA to apply to pressurized rover as a smart lunar vehicle. So today's theme is smart lunar mobility. Then we proposed to use a pressurized rover for fuel cell system. Thank you for my short presentation. That's all. Thank you.
Thank you so much, Junichi-san. Now I would like to invite Derek Hodgins from Lockheed Martin. Please, Derek.
I appreciate you. I'm share my screen. Maybe you can see it.
Yes, perfectly well.
Perfect. So I appreciate the opportunity to talk today. Exciting times. You know, Lockheed Martin, while maybe headquartered here in the United States, is a global company operating around the world, including in Japan. And our lunar mobility vehicle, which we'll talk about over the next couple minutes, is really a global endeavor. And so I'm proud to be joined by our partners at MDA in Canada. Very interesting times with the Artemis program starting up. and interesting opportunities start building off of our colleagues at Toyota, as far as bringing in non-traditional companies into the space industry and being able to leverage technology there. So we'll talk a little bit about that. I'm going to start off with just a short video showing our LMV. While this plays, though, I'll kind of talk through it. The most interesting part about this is really that this will be the first level 5 autonomous off-road vehicle ever designed. It's designed to survive the full 14-day lunar night. Now, people talk about lunar night survival, peaks of eternal light. We've been designing this vehicle and developing this vehicle to effectively unlock the full surface. Now, you put together full autonomy along with the full 14-day night survival, and you're really unlocking the access to the lunar globe. You're not constraining yourself to the range of peaks of eternal light. You're not constraining yourself to low speeds. There's a number of different small shoebox rovers going to the moon. You're talking about speeds far, far less than a kilometer per hour. I think NASA's Viper rover has an average speed of about 0.1 kilometers per hour. We're talking about something with the ability to traverse fully autonomously of 8 kilometers per hour. So we're talking 80 times faster, just with leveraging General Motors autonomous vehicle technology. The other part in this is a little discussion on fuel cells, and we had traded fuel cells and batteries. One of the interesting parts is to be able to have what we call, I guess you could say, a sustainable and sustained vehicle. Being able to leverage, not having to deliver cryos to be able to refuel a vehicle, leveraging GM Ultium battery technology. And one of the fascinating things along the lines of what we're talking about today is we have taken those GM Ultium batteries and put them through thermal vacuum testing. We actually have a flight demonstration, an actual in-space flight demonstration launching early next year that is powered by Ultium batteries. So exciting times as far as for not just increasing power density and being able to support a vehicle using solar and leveraging that, but also in bringing in low-cost technology into our industry. I mentioned our partnership with MDA, leveraging their just unparalleled robotics technology has been a boon for what we're developing. And when I say that, one of the also very interesting parts is that this vehicle is in development. When we talk about industry and government partnerships, for example, NASA's commercial cargo program was approximately 50% government funded by the United States government and 50% industry funded. Commercial Crew is about 7% industry funded, 93% government funded. What you see there on the screen is 100% industry funded. Lockheed Martin and General Motors are not exactly risky companies, as I'm sure we can all attest. But we have closed a business case over the course of 12 months that has been approved through our CEO level of both companies. And so this vehicle that you see there is actually in development. We are building it. It will be on the surface in 2025. We're looking at this as a key enabler to both robotic and human exploration. I mean, humans are only going to be there for 1 week out of the year. The other 51 weeks, this is a robotic vehicle. And being able to do things like deploy payloads, deploy small shoebox rovers that otherwise would die before they were able to get to the interesting places, since you want to land on nice, even, level terrain. But the interesting places are the ones that are rocky, the ones that are in and around craters. Again, less than 0.1 kilometers per hour, there's a solid chance something's going to die before it ever gets there, before the night takes it out. So we've designed this to be able to deploy those small, tiny shoebox rovers. I mentioned this survive the night, the full 14 days, being able to also operate during the night. Again, every minute that this rover sitting on the surface and is not doing anything is another minute that can't be monetized. And is that business case, being able to do these things through the night, helping other payloads, helping small rovers to survive the night, really is a key enabler to what we're building. And then looking towards the future, the infrastructure that we're going to need to be able to have our long-term presence on the lunar surface. The simple things that you use mobility for here on Earth are the same things we'll use it for on the moon. Everything from deploying, from excavation to transporting materials. Transporting humans is just one small part of it, and we're really designing to do both. And then ultimately, we're looking at mobility in larger classes, using the LMV, using what we are developing right now to inform larger chassis vehicles, such as ones that can transport habitats, transport nuclear reactors, be the foundation of a pressurized rover, transport large-scale materials, again, things like in situ resource utilization, but really developing common technologies, common systems to inform really large class mobility as well, again, for that sustained and sustainable presence for Artemis. But a lot of exciting times, and it's been interesting to see non-aerospace companies coming into the fold and being able to support Artemis. So proud to be partnered with General Motors and Goodyear, and also again our friends from MDA, which we'll be hearing from. So thank you.
Thank you so much, Derek. Thank you. I give the floor now to the MDA representative, Faizan Rematullah. Please, Faizan.
Hi, everyone. This is Faizan Rematullah from MDA. I'm going to talk a bit about the work that we've been doing, working on rovers for planetary exploration, and sort of the projects that we have been working on for almost like a decade now. So MDA has been working on lunar and Martian rovers for more than 10 years, and over the course of that time, we have developed conceptual designs ranging from micro rover all the way up to very large scale rovers that are capable of carrying heavy payloads. We've also done a number of terrestrial prototypes and flight missions. I'm just going to highlight some of the key technologies that we have been developing over the years as we have been advancing the lunar and particularly like the overall planetary exploration technologies. So the image that you see here is of the Lunar Exploration Light Rover. This was a prototype that was developed for the Canadian Space Agency, and its objective is astronaut transport and scientific exploration on the moon. The vehicle is one of the largest and fastest in the CSA's rover fleet, and it has requirements that are very similar to the NASA's LTV requirements. So it's capable of carrying astronauts, and it's capable of also conducting science operations. This project, we successfully partnered with Bombardier Recreational Product. That was our partner to develop the chassis and the locomotion system. And they then took the technology that they advanced working on this prototype over to some of the products that they built, the follow-on products that they built for their recreational market segments. We also developed the mobility subsystem for the ExoMars rover. The image that you see is of the flight model of the mobility subsystem. And MDA was responsible for building the actuators, the suspensions, the wheels, as well as the actuator drive electronics. This is a triple bogie suspension with flexible wheels, and this is where we really worked on qualifying like a design for extreme environments. Martian environment is not as severe as lunar environments, but you can get fairly severe dusty environment, and temperatures and the survival temperatures can go down to minus 125 degrees. So this was a project where we took our technology, advanced the dust sealing technology. How do you protect your mechanisms from dust ingress as well as cold temperature operations and developing of technologies for working in these harsh, really ultra cold environments. As a follow-on contract after the ExoMars rover, we started working on the mobility subsystem for the sample fetch rover. That program has been so the sample fetch rover has discontinued once the Mars sample return architecture was rebaselined. But over the last 2 to 3 years, we advanced this mobility system concept, which is a 4-wheel, all-wheel drive, all-wheel steering system with rocker differential suspension, and we took it up to a phase B level. And as part of that effort, we built the characterization breadboard that you see on your screen. So this is a prototype rover that was used to conduct an extensive test campaign in 2022 to characterize the system. How does it work on slopes, various soil simulants ranging from fine powder, regolith, its capability to climb obstacles, impact loads, driving over rock beds. So we took this platform into a simulated planetary environment and conducted a full suite of characterization tests that enabled us to validate the mobility technology. Now, the interesting part is that the work that we've done here is readily portable to the lunar environments. In fact, the wheels that you see here actually have an interesting history. They started with the lunar roving vehicle that NASA built back for the Apollo program. The technology was adapted by GRC into this wire mesh wheel, which now has its path back to the moon as well. Finally, I have a video of our Mars Exploration Science Rover. So as part of the program where we developed the Lunar Exploration Light Rover, we also built a prototype rover called the Mars Exploration Science Rover. The video that I'm playing is of a GNC, guidance, navigation, and control test campaign that we did with that platform. So we've also been working on the guidance, navigation, and control technologies for a long time, and our algorithms are portable to different vehicles. In this case, you see an instance of this Mars rover in Utah that is going through a sequence for navigation in this unstructured environment. And I'll just walk you through the steps of what the system is performing at this stage. So once the vehicle stops, it conducts a scan of the environment in which it's in. It creates a 3D map of that environment. The vehicle then processes that into a cost map. It identifies what regions are feasible, where the obstacles are, and then identifies a path from its current position to the edge of the sensor horizon, and then executes that path to get to the end of that segments. And then it repeatedly performs these operations until it gets to the destination or the goal location. So that's in a nutshell some of the key enabling technologies that we have been working on in terms of the lunar and Mars exploration, and just a varying set of technologies for operations in extreme environments, autonomy, and in the next segment I'm going to talk more about how we're now porting this over to the lunar projects. Thank you.
Great, thank you very much, Faizan. And now we go to Lunar Outpost, and I invite Justin Cyrus to share with us his view graphs. Justin, please.
All right, fantastic. Can you see my screen?
Yes, we can.
Perfect. All right, I'm going to give a quick background on Lunar Outpost, and then I'm going to spend the rest of the 5 minutes talking about autonomy, which is one aspect of smart mobility. Now, Lunar Outpost, we are a company headquartered here in Golden, Colorado, focused on creating autonomous systems that enable sustainable presence in space while improving life here on Earth. And this is a quick background on our team. And we have around 60 people now. We're on track to be around 80. So still a medium-sized company, but growing quite quickly. And this is the NASA administrator handing us the first check in human history for space resources, which we're quite excited about. And we'll be accomplishing that milestone as part of our first mission. Here's where we're located. As I said, we are headquartered here in Golden, Colorado. We do have our European headquarters over in Luxembourg City. However, we do have access to around 1,000-acre test site in Southern Colorado, where we do sustainability testing and extreme environment testing for long durations of time. Now, what we provide is lunar mobility services, and Lunar Outpost is uniquely positioned that this is really all we do as a company, autonomous systems for extreme environments. And of course, true to our namesake, one of those environments is the lunar surface. We have found ways to commercialize that in extreme environments here on Earth, and that has led our company to a fairly high growth scenario. This is a picture of our flight spare for our first mission. So one thing I always like to point out, these rovers are built and they're going to the moon very soon. This isn't something that, you know, is going to be next decade. This is something that's happening now, and we're quite excited about that. Now that you have an overview of who we are as a company, where we're focused on utilizing smart mobility and specifically autonomy is to enable hundreds of mobility systems on the moon. And I think my fellow panelists from Mitsubishi said it, we're going to need hundreds of these mobility systems and different types of mobility systems to truly enable a sustainable cislunar economy. And they'll work together not only to build and maintain infrastructure, but to support astronauts and access resources as well. Now, what I'm going to do is basically take you through our first 3 mission profiles and talk to you about how we're using autonomy in each of those profiles. So our first mission, and you saw actually the picture of that flight spare rover earlier on, is going to the moon actually within 6 months, which we're quite excited about. So this will be the first rover in human history at the lunar South Pole. So we will be collecting data, which is quite exciting. It's a precursor to those Artemis missions. You really need that data to enable confidence in your human landing system missions and later on your LTV missions as well. And we are launching on a SpaceX Falcon 9, landing on an Intuitive Machines Nova C lander. And this is a fully commercial mission, which I like to point out. This was not sponsored by NASA. We did not have a contract from NASA to make this happen. We went out and sold commercial payload space that drove this mission to profitability, which was a big milestone for our business and I believe the cislunar economy. So our main customer is Nokia, who is putting 4G LTE on the lunar surface. And I know people are already talking about 5G, but frankly, let's just get some communication systems up there so our robots can talk and can interact not only with the lander systems, but astronauts and other robotic systems. And what we're doing with autonomy on this first mission is quite simple. I don't think going after level 5 autonomy right off the bat is going to be possible due to the extreme environments on the lunar surface and its very unique characteristics compared to environments here on Earth. Autonomy is something that automotive companies have spent billions of dollars researching for well over a decade now. So we certainly think that this first mission, let's just hit the base goal of waypoint autonomy. Now, this is something that's already been proven on the Mars Perseverance rover. And we as a company actually do already have planetary heritage on Mars as part of the Mars Perseverance rover and the MOXIE instrument led by Dr. Forrest Mayan on our team. But we certainly learned that even with waypoint autonomy, there were challenges as a part of that rover. So what we're doing here is waypoint autonomy. We basically tell the robot where we want to go. It figures out the most efficient way to get there. Now, as we start moving on to our second mission, and this is quite exciting. So this rover is a little bigger. First rover is around 10 kilograms. Second rover is around 20 kilograms. This is a fully funded NASA mission going to Reiner Gamma. So this is a magnetic anomaly on the lunar surface, which we are carrying a magnetometer from Johns Hopkins Applied Physics Laboratory and a microscope sponsored through JHU APL, actually built by a small company up in Canada. So what that is going to provide us is some very interesting information, not only about the formation of the moon, but the formation of our solar system. And what we're doing to push the bounds of autonomy on this mission is we're not only looking at autonomy during the lunar day, but we're actually shooting for what can we do to start surviving and operating during that lunar night, which is quite exciting. Again, this is a mission that is already booked, already launching. This will be launching in a little over a year. Again, on a SpaceX Falcon 9 and Intuitive Machines Nova C lander. But now when we start looking at autonomy, what happens next? And this is where it gets quite exciting. All right, we already have waypoint driving from the first mission, and that's proven that's TRL-9 at this point. Now, instead of telling the robot where to go, we give it a set of parameters. And while this is not a mission requirement from NASA, this is something that we're able to test out in the mission parameters, of course, pending the initial successful mission profile. But what we can do is give the rover a task, a mission, say, find us the point of the strongest magnetic field in this localized area. And instead of us telling the rover where to go, it actually decides where to go based on the input from the magnetometer, of course, the wheel odometry, the IMU, the cameras, and the other sensors, but it can find the local maxima, and then it will report those values, and it will do it much more efficiently than a human operator will. Now, this is extremely important as you start building out towards swarms of robots working together. They not only need to be able to communicate to the operators, but to each other. Hey, I have a point of interest over here, whether it's in this case, a high magnetometer reading, or in future cases where we're prospecting for water ice. This is an area that could be rich in water ice. This is an area we should prospect more. And our robotic systems are able to start figuring that out by themselves. Now, as we start pushing towards our larger and more capable vehicles, we are partnered with Northrop Grumman, Michelin, and AVL and Intuitive Machines on an LTV rover as well. Now, this is a larger system that will benefit from that TRL-9 autonomy that we see from our first two missions. But certainly, and something I think many of the panelists can probably attest to, LTV is only going to have astronauts on it for a very small portion of its lifespan. So what do we do with the lunar terrain vehicle when humans aren't there? And I think this is where autonomy becomes extremely important to maximize the scientific value and the overall value that you're getting out of the lunar terrain vehicle. And so with that applied autonomy, not only can you have what we talked about in the last rover, which is given a set of parameters and a fixed set of scientific payloads, it can operate on its own. But now with LTV, you're talking about potentially having modular payloads. And I think this is something that NASA is very interested in. Many LTV teams are looking at this. But what's different about Lunar Outpost is we can take those modular payloads and work that into our autonomy stack. So if you do have a drill and a prospecting piece of equipment, or if you do have some swarm capable technologies on this to talk to, let's say, the human pressurized rover, or to talk to smaller rovers, this vehicle will be able to not only work with other LTVs of its kind, but multiple different types of robotic systems and multiple different instrumentations and operate autonomously, which is quite exciting. So that's all I had for that portion. Certainly happy to take any questions once we're to that portion, but thank you.
Thank you so much, Justin. Thank you. And this brings us to the roundtable discussion directly. And we have got quite a few questions, but let me start with the ones which are written in the Q&A part of our interactive screen. So let me start with the question from Nico Steinert. I understand that it's a question to everyone around the table. How the dusty environment is considered in the designs of the presented rovers? The dust is seen as very critical for the operation due to the abrasive characteristics and the electrostatic charge. Who would like to take this question, please?
I'm happy to hop in since I still have my camera on. The dust is an extremely important part of the lunar environment. And I think it's an excellent question. Our CTO actually spent 8 years at the Laboratory of Atmospheric and Space Physics up at University of Colorado Boulder. And so this is something that we've been very cognizant of. And certainly I think this plays very well into the next section. What is that supporting infrastructure you need? Do you need repairs? Because you have to interact with this very geotechnically challenging lunar regolith. Does your rover need to have electrostatic technologies to mitigate dust ingress on the rover or dust covering on your lenses? But I can tell you how we are dealing with it on our first 2 missions. So we actually have deployable lens covers, and this is nothing new. This is something that's actually seen on a few of the Mars rovers. But as we start building out towards these capabilities, they do have to be proven in the lunar environment. So, when we're landing, basically we come down, we get off the lander, and our system can measure the amount of dust buildup on that front camera lens. And once that dust buildup gets to a certain point, we basically eject the front lens cover, and then we continue the rest of the mission. Now, that type of dust mitigation is only so useful because it can only be utilized once during the lifetime of the mission. Of course, you can have multiple different lens covers, but that does get complicated quickly. But building towards what I think your question is, and I think it's a great question, potentially utilizing electrostatic charge to mitigate dust. A lot of work is being done in that field, and I think there are some leading scientists there that are looking to test out those technologies on the moon. And my guess, and this is simply a guess, is through the CLIPS program that NASA is running, most likely we will see some sort of dust mitigation technology proven out before humans land there in 25 and 26.
Okay, Justin, thank you so much. And I see that there is another question from Francois Dubrul, who is MVA member with his Cosmosis company, which is, by the way, on the way to deploy its own lunar lander. But the question echoes a little bit the previous one. How do you manage a regolith electrostatic effect and pollution to the rover's mechanisms and electronics? So unless someone would like to add something, we can leave this question to the second part indeed. Anybody wishes to reply immediately? Okay, so there is another question from Brück Spindler. Do you consider nuclear power systems as key enablers? Who would like to take this one?
Yeah, I can take that. It's Derek at Lockheed. So we hadn't gone public and announced the work that we've been doing as far as for nuclear in space and surface applications for fission surface power, nuclear thermal propulsion. We talked about this, I think it was about 2 months ago, like I said, publicly. And we look at the sort of, not just the lunar future, but also, if people say moon to Mars, we're looking at it as moon and Mars. And what are those technologies and what are those capabilities that you need to be able to do both missions? And it's, game-changing development has been one of the catchphrases going back 10 years. We look at, nuclear as a game-changing development, both in being able to transport crews, being able to cycle between low Earth orbit and the moon, absolutely would be, it's game changing in its possibilities for transporting things to being able to bring things back. And also on the moon, being able to provide safe and stable power sources. That's part of the reason that we've been looking at larger, mobility systems, such as the vehicle that you saw in my presentation. And so, yeah, nuclear we see as a very key part of that future. And like anything, it's not necessarily an or when it comes to power sources; it's an and how all these things work together between solar and nuclear as far as in surface infrastructure.
Okay, Derek, thank you so much for your reply. We have got a question from an anonymous attendee, and it's directed to Justin. Why did you choose Intuitive Machines as your rover sender out of some of CLIPS companies? Please, Justin.
Yeah, and it's a very good question. I think there are a lot of very capable CLIPS providers out there. Certainly with our first commercial mission, it was not only the fact that Nokia was already working with Intuitive Machines, so it was a very good match there, but we did believe that they had a very good path to spaceflight. So we felt that after visiting them, after visiting their facilities, talking with them on the phone, and we got to know them over the course of the 4 months, that Nokia was actually vetting us. And actually part of the story, probably many of you don't know, is we went through quite a serious vetting process with Nokia. It was us and 3 other rover providers, but what differentiated us is we had hardware that was working in a relevant environment, which at the end of the day, Nokia was very excited about. But going back to why we ended up choosing Intuitive Machines, we felt like they had a very good, clear path to spaceflight. We had a high degree of confidence that they would be able to deliver us to the lunar surface successfully. And that's why we chose them for the first mission. Now, the second mission, that was actually chosen by NASA. So it was just a coincidence that NASA ended up choosing the same launch and lander loadout that we had in mission 1, that Falcon 9 and on launch and Nova C on landing. But certainly what I would say is there are very capable CLIPS providers, and we're extremely excited that companies like Intuitive Machines are, and others. I think we just saw iSpace launch just a couple days ago. There are many companies that are putting together this transportation layer to the lunar surface that is going to be critical for long-term sustainability and cislunar economy. I actually did have a slide on this in the next section, what that transportation layer needs to look like for us to actually make space sustainable. And I do think Intuitive Machines is certainly one of those companies that's leading the charge.
Okay, thank you so much, Justin. I see no other written questions. That's why I would like to address to you mine. So we have seen from your presentations that after having worked for quite some time, for several years already on the respective projects, you managed to identify some critical aspects of the future missions. For example, MHI told us that there are key technologies, 4 key technologies to be dealt with. We have heard from Toyota and others that there is a critical issue related to the batteries, etc., etc. So you could probably already speak of some lessons learned even at this point. And you can probably try to identify the most interesting and the most challenging areas of your work. Could you please share with us your thoughts on this?
Yes, I'll go again, and I'll also look to MDA to expand upon this, since they've been working this directly with us and us them. There was a comment that was made a few minutes ago concerning the autonomy system, and what's fascinating about it, what I think really fits into this this first section, is those billions of dollars have been put into it. And I know I'm sure Toyota can echo this as well. GM has put $7 billion into autonomy systems, and it's been absolutely phenomenal to see how far that has come and to see off-road autonomy. There's an interesting story when we first met with GM and talked about the lunar environment and the landscape and how that is challenging for any autonomy system. And the chief technology officer of GM looked at me and says, "At least I don't have an 8-year-old running in front of my Rover." So it's incredible the way that we're able to leverage the, like I said, $7 billion of investment by GM, $30 billion in batteries. Again, I know Toyota can echo this, to be able to develop level 5 autonomy. It's absolutely mind blowing. And the fact that we're not just on the cusp of proving the technology, but we're actually building a system, literally assembling it right now to do that is really a boon as far as for enabling technologies. I guess anything to add, Faizan or Lori?
Yeah, I can add to it that I mean the projects that we've been working on, specifically on how do you operate in these extreme environments has really been good lessons learned. All the investments that have gone into figuring out how you would seal mechanisms in dusty environments. How do you operate in extreme temperatures? All of those lessons learned are ported into the vehicles that we're working on now. And then there's a whole array of complexity that comes from operating these vehicles. So, how do you effectively make use of the platform as you're operating it remotely? So all the investments that have gone into conducting terrestrial missions, analog missions, working on the ways in which the autonomous systems can operate in these environments are all the lessons that are imported into the future vehicles.
Okay, thank you very much, Derek and Faizan. I completely agree with you. It's extremely impressive that the companies participating in these projects heavily invest in the developments. We have heard also from Toyota, from Lunar Outpost, that the figures are really very, very significant figures of investments. So it comes as a natural conclusion that the companies can see the future business in these areas and can see their business niches in the nascent moon market. As you may know, I have mentioned this in my introduction. Moon Village Association has issued recently the first version of our lunar commerce portfolio, where, among other things, we have tried to project future revenues or future potential income for the companies participating in the moon endeavor. Did you do something in your companies similar? Very rough, maybe estimations, because if you invest at the level of billions of dollars, you should be not even, if not sure, then to have a certain degree of sureness, I would say, that this money could be recovered somehow in the future. What can you tell on this?
I'm happy to hop in just from a high level, and then certainly would love to give some of the other panelists a chance to touch on this. We have done quite a bit of work on looking at what that not only lunar surface, but the entire cislunar economy is going to look like. And I know folks, the large primes of course have as well, your Northrops, your Lockheeds. But I think what's interesting, what has provided us some very positive early data towards proving out that business plan is the fact that we were able to run not only this first mission commercially, but we were able to charge services towards our second mission, and then we're building towards missions number 3, 4, and 5 right now. So we have real world data on what people are willing to pay to get and operate on the lunar surface and what services they're willing to pay for. And I think a big part of smart mobility, and part of the reason why I was so excited about this panel here today, is when you start utilizing the term smart mobility, it's not only just driving astronauts around, it's not simply small rovers just prospecting on the lunar surface. Now you're talking about utilizing rovers to truly build out large-scale infrastructure and maintain that over time towards that sustainable presence. And what I can say from a high level is I think that infrastructure layer, and we're going to talk about this here in a second, is going to be a big part of that economy over the course of the next couple of years. And then certainly, just as with any infrastructure layer, once it's put in place, there are going to be thousands of companies that are able to step in and utilize the infrastructure layer that's put there for these original purposes. And a lot of that bill will originally be paid by government space agencies and others that are partnering with them. But once we have the not only transportation, but power, communications, the rest of the infrastructure layer in place, I do think we can start building towards that more end user economy like we're used to seeing here on Earth. And it's one of those things that a lot of investors you talk to, especially we had 2 out here last week that were very early in Silicon Valley in the internet days. No one knew what the internet was. No one knew how they were going to use it. But the moment that the back end, that infrastructure layer got put in place, then people started building multi-billion-dollar companies off that infrastructure layer. So that's where we see the trajectory of the economy moving forward.
Okay. I see your arguments. Justin, another question from Francois Dubrul. What are basically the lifetime of your rovers? Maybe we can address now the question to our Japanese colleagues. So the question is, what are basically the lifetime of your rovers?
Is that the question to me?
For example?
Yeah. About 10 years.
About 10 years. Okay.
Yes.
What about others?
Yes, 1 year.
1 year. Okay.
The 10 years, 30,000 kilometers.
Oh,
yeah.
Okay. Okay. There is another question about the public outreach. Do you work in this direction somehow? Do you consider it as being an important part of your business case promotion?
I guess I'll take that one. I would say it's a critical part, and it's a really critical opportunity. Partnered with well, let me back up. I would say that this is an opportunity where we're creating something where people find space interesting, and we're making it tangible. Almost everybody on this planet has been in an automobile, vast majority, and we're taking something that is really, outside of the average person sort of knowledge base, but they find interesting, and making it something tangible by having rovers. And that's been part of the reason that we've gone to building a large class rover. And it's also been part of how we're able to close a business case. I mean, nobody that's building a small rover should be expecting a dump truck full of cash. However, if you want to be able to, as Justin said, kind of get to that, sort of longer term infrastructure based, really business case, it has to be done with larger scale mobility. And as I mentioned earlier, Lockheed and GM are not exactly risky companies by any stretch of the imagination. And it was a very, very deliberately done process, like I said, over the course of about a year, to close a business case. And the public outreach portion of it was a huge opportunity with it. I mean, you're talking about leveraging companies that spend $4 billion in marketing a year, and being able to just leverage that for the interest, if nothing else, has a significant tangible value to that as well. And you marry that with being able to do things in education And how cool is it, somebody can put on a helmet and effectively put themselves on the lunar surface, controlling a vehicle that can move like they do, that has 4K cameras looking all around. I mean, it's just absolutely phenomenal opportunities.
Exactly, Derek. Thank you. I know that in Japan, the guys from iSpace with their Hakuto R mission, and generally the company is like superstars, like Hollywood stars. Everybody seems to know this company, what they're doing. I'm wondering if MHI and Toyota is putting the same efforts in the promotion of their project within the country and to the wider general public. Who would like to answer? Junichi or Hiroaki, please. What are you doing in terms of the outreach?
To reach. Can you say again?
So, do you promote among the general public your project?
Yeah. Now we are on under the research condition ongoing now, so we are not going to promote at the moment now.
Okay, so it's not a good stage yet.
Yeah.
Okay, good. I think we can wrap up now with the first roundtable and in general with the first part of our event. And I will be more than pleased to pass the floor to Naoki-san to start the second part of the event.
Okay. Can you hear me now?
Yes.
Okay. Thank you very much. So we are going to next topics, which is the infrastructure to support the lunar mobility in the next decades to come. So again, we'd like to continue the presentation from 5 participants. The first one should be Mr. Kodama with MHI. You have a floor.
I'm sorry. I'm in trouble with my PC now, so please wait a minute. Please go start with
change?
Yes. Sorry.
May I change the order? So Yamaguchi-san, could you be first?
Yes. Just a moment. Can you see this?
Not yet.
Okay, so I will share.
Yeah, now we can see your presentation. Yeah,
Okay.
that's perfect.
Okay, thank you. The second theme is infrastructures to support lunar mobility. As I mentioned in my last presentation, fuel cell application using ground technology will support smart lunar mobility. I think it will be good to apply ground technology to infrastructure, same as the lunar mobility. So I will have a short presentation. Hydrogen society at Moon Village utilizing lunar water resources. In near future, the water resources will be found at the lunar surface, and the water may be applicable to the sustainable energy on the moon. Lunar water resources and solar power will produce the oxygen and hydrogen by water electrolyzer. And oxygen and hydrogen makes electric power through the fuel cell. Lunar mobility utilizes the electric power. After power generation by fuel cell, the water is reproduced. Then using that water by electrolyzer, then make hydrogen and oxygen will lead to the water circulation on the moon. As an infrastructure, ground technology to the moon. The first ground technology, I will show you the hydrogen station in the city. To live on the moon, not only using the solar power, but also the hydrogen plus oxygen station will be expected as a viewpoints of power storage and power supply due to the high energy density. So if the power station like hydrogen plus oxygen, A, B, C, D, E, and so on is existing, it will be very happy for the rover or the moon villages. As a viewpoint of second one will be the portable hydrogen cartridge, which Toyota is now making a prototype on the ground, which is expected as a viewpoint of power storage and power supply. The hydrogen and oxygen charging is very quick. And using that hydrogen oxygen station or portable cartridge, then the lunar mobility is possible to move. And more, the pressurized rover have lots of energy for fuel cell systems, and it is possible to supply the electric power to the moon villages. That is the ground technology, so-called vehicle to home (V2H) is possible. Then, using such infrastructure related with the fuel cell can contribute to the moon villages. That's all. Thank you.
Thank you, Yamaguchi-san. Great presentation. So next speaker will be Kodama-san. Are you ready?
Yes, I'm ready.
Okay, please go ahead.
Can you see my screen?
Yes.
Okay.
Go ahead, please.
Okay. For topic 2, I will show you our scenario to develop the society on the moon. We divide the scenario into 4 stages. Step 1, the robotics exploration prior to the manned exploration. Resource prospection, such as water, and first outpost construction will be conducted. Step 2 is manned exploration. A basic infrastructure such as power, communication, a pro plant will be constructed. And step 3 is expanded manned exploration. Constructions for long-term stay will be needed. Finally, large-scale village such as lunar domes, hotels will be formed. As an advanced base-to-mass facilities for the sustainable human activities. To expand our technology and knowledge, which I introduced at the beginning of my presentation, we are planning to provide free of services as essential service in the lunar society. First is lunar port. This will provide the launch and transportation service from the Earth to the Moon, and also provides navigation support for the transfer vehicles. And the second is a propellant plant, generating the propellant from ice contained regolith. Several technologies are needed, such as mining, processing, and storage. And third is habitation service. We will provide a regenerative ecosystem, which is needed for sustainable manned activities. This is our milestone for the service in the lunar society. We would like to start the technical demonstration on orbit in this decade, in early or middle of 2030s. We hope to start these services. By success of Artemis 1, we feel that the door to our challenge was opened. The distance is still far, but we'll advance steadily by repeating success. Thank you very much. This is all for my presentation.
Thank you very much. Very wide range ideas and very attractive roadmap. So next speaker is again the Derek from Lockheed Martin. Are you ready?
Yep. So I'm just going to show this this one chart, and you saw this in a little bit in the video earlier. The way we're looking at this is a mobility-driven infrastructure. And again, everything that we use mobility for here on the Earth is the same things that we're going to use mobility for on the Moon. And we're looking at when we talk about our vehicle, standard interfaces, mechanical power, and data to plug in things, whether it be a drill, a plow, small rovers that can be deployed, landing beacons, landing pads. In other words, sheets to be able to protect the surface when landers come down to not kick up regolith, but effectively being able to deploy the infrastructure, being able to have mobile power, beaming mobile power, charging. So really trying to, I guess, taking a mobility focus to deliver this infrastructure, because we see it as something that's not just necessary for our first arrivals and first missions on the Moon, but these systems are going to be required for the long term as well. And again, need to be scalable to be able to provide the same type of capabilities for large scale infrastructure. So as I mentioned, we've been doing this, working this very deliberately, and as part of a roadmap. And the one thing I do want to accentuate here, as you hear the other panelists, is that this is something that requires everybody. It's not just one company or one team of companies. This does require the large scale, small scale. This does require really working around the world. The automotive industry is an ecosystem of partnerships and competitors that drive each other. General Motors and Toyota just sampling as far as partnerships in this call. So we really are looking at this as a global endeavor. So it's been pleasure and honor to be able to speak with these speak to you with these other panelists. So thanks.
Okay, thank you very much. So next speaker is the Faizan from MDA. You have a floor.
Yes, Thank you. I'll share my screen. So as Derek mentioned, the really developing infrastructure on the lunar surface requires having mobility and robotics. And that's really the focus of the work that we're doing with Lockheed Martin, General Motors, and Goodyear on the lunar mobility vehicle. And this is a vehicle where MDA is bringing in the technology that we have developed on Canadarm, together with all the work that we have done on planetary robotics. Understanding how to work in dusty environments, extreme temperatures, to support this project. And I think that this is where you need these sort of mobility platforms paired with robotics to deploy the lunar infrastructure, construct the elements of the lunar infrastructure, and you really want to capitalize on the time that these platforms are there on the lunar surface when there are no astronauts, and to offload much of the work off of the astronauts to reduce the EVA time, so that when the astronauts are there, they're focused on working on the operations that are specific to what humans are good for. And so this is a project where MDA is working on the robotic arm in partnership with Lockheed, GM, and Goodyear. We're also looking at development of large mobility platforms that are what we would say the ultra class. These are modular platforms that are designed to carry heavy payloads across long distances. And here, you really have these, 2 to 3 ton platforms carrying payloads in the range of like 6 to 8 tons. And these are your workhorses that are going to do large scale infrastructure work, very, very similar to how you see terrestrial vehicles, large terrestrial vehicles that are used to develop infrastructure here on Earth. So I have a video of just the animation that shows some aspects of how these very large vehicles can be used in constructing infrastructure components on the lunar surface. So here you have the vehicle that's lining up with the with another 4-wheel version of the vehicle, and you have a shovel or a digger to excavate. You're basically using these large vehicles to perform excavation operations or to pave the roads. So because interestingly, to construct roads, you need these mobility platforms to clear out the regolith and construct these paved surfaces where the rovers could drive on. There's also the need to transport heavy components from one location to the other. In this animation, you're looking at a habitat being transported from a lander over to the mobility platform, which can then drive it to its destination. And so we really see these pieces like the large mobility vehicles together with robotics as a key enabling technology to support construction of lunar infrastructure. Thank you.
Thank you very much. very interesting movies and ideas. So last one is the Justin from Lunar Outpost. You have a floor.
Thank you. And just confirming everyone can see the screen.
Yes, I can see.
Excellent. So, certainly we do agree with MVA and Lockheed. It's good practice to bring what you need with you to accomplish a mission. But as we start building out towards that larger vision that was presented by Mitsubishi, that multiple habitats, that large scale infrastructure, those lunar cities, if you will, there are pieces of infrastructure in place that I think are critical to not only increasing the capabilities of your mobility, but also increasing the efficiency of your robotic systems on the lunar surface. So I'll walk you through 3 sections of infrastructure: fixed infrastructure, mobile infrastructure, and then what we'll classify as additional infrastructure, which is a bit of a catch-all category at the end. Now, for the fixed infrastructure, we are going to need items like launch and landing pads for large payload deliveries. And this is something that mobility systems can certainly build. And for those of you who have been following the news out of NASA, Lunar Outpost did win the first launch and landing pad construction contract through a program called Luster. And our project name is Aspect. So 103 applicants, we actually ended up being the only selectee on that. However, recently, another company called Icon, which is a 3D printing company, also won a launch and landing pad contract through a different part of NASA, through the SBIR STTR program. They went through phase 1, phase 2, phase 3, and they ended up with a $56 million contract to build these landers. So it does show that space agencies are starting to shift in this direction. What infrastructure do we need to enable this long-term sustainability? And then, as MVA actually just showed, you do need offload capabilities from the landers. And I thought that was a pretty cool animation. And I think it's a great point. Certainly, as we get larger landers, we start getting these launch and landing pads in place, we will need to be able to offload tons of material from these landers and get them onto mobility systems for delivery. But as we start looking towards more fixed infrastructure outside of the transportation layer, you're looking at power for recharging. Now, I saw a question earlier about nuclear material. Can that be utilized? The short answer is yes. Technically, it can be utilized, but the biggest issue you have with nuclear material is not necessarily the technology, but simply the red tape that you get with trying to send nuclear material into space. So there's going to be a lot of challenges for commercial companies to try to utilize nuclear material on the lunar surface until there's a better way of getting approval for that. Right now, it's a very long, slow, expensive process. So I think we're going to need vertical solar panel arrays. We're going to need power beaming. I think Derek referenced that as well, but certainly other types of fixed infrastructure in place to support the mission of smart mobility. And as we start looking out, so something, and again, I'm happy to share kind of the experience we've had on our first mission. We have to utilize communications from our lander with our first mission. As we start building out on mission 2, 3, and 4, that paradigm changes a little bit due to companies putting in place orbital communications. Now, orbital communications, I think, is going to be an extraordinarily important part of exploring and having that sustainable presence on the lunar surface, because if you are reliant on a lander for communications and that lander does not have lunar night survival capabilities, doesn't matter if your rover can survive the lunar night, survive for 10 years at a time, you have to be able to communicate. So a lot of mobility companies are not only looking for that direct back to Earth type communication, which is very possible. It just is a very low bandwidth, unfortunately, right now. But those orbital communications and those orbital relays back to Earth that offer a higher bandwidth solution. Now, again, something that mobility can help build, but roadways. Roadways, obviously, here on Earth do offer significant efficiency gains in terms of mobility on the lunar surface. mobility on the Earth's surface, and will also offer similar efficiency gains for mobility on the lunar surface. So it's great to have off-road vehicles, and all mobility systems that are going to the moon in the next 10 years should absolutely be able to off-road. But as we start building towards efficiency, we do need to get roadways in place. So the next section we have is mobile infrastructure. And this is similar to what some of the other panelists were talking about. I'm just going to give you 3 specific examples. So in the background, you can see a picture of a few rovers digging in a permanently shadowed region. So for example, what would you need for those rovers to dig and deliver material in and out of a PSR? You need that deployable power. So that vertical solar array technology we were talking about earlier, or the fuel cell technology that Toyota was mentioning, which is quite exciting. But then you also will need either mobile repair hubs that can be positioned outside of permanently shadowed regions and support robotics, because operating at these temperatures with that very harsh lunar regolith, and we're not quite sure what the material is exactly down there. It could be as hard as concrete in these permanently shadowed regions. There could be a fluffy layer of lunar regolith on top. We're not quite sure, but either way, at those temperatures with this type of material, you're going to see an extreme amount of wear on your robotic systems. So you're going to have areas where you can repair your robotic systems, whether that's a hub or just support robotics that are operating in more benign environments. And then communication relays. A lot of areas of interest, including permanently shadowed regions, you would need infrastructure on the lunar surface to get high bandwidth communications out of the permanently shadowed region. So that communication relay is an example of mobile infrastructure that will be needed to increase the efficiency of smart mobility. And then additional support infrastructure. So this is not talked about very often, and this is something I would like to talk about here just for a moment. We do need an investment into more capable ground station hardware here on Earth. Although there's dishes all around the world and each of them has a varying set of capabilities, there are some areas where there could be improvements, especially when we start looking at that whole communications architecture from the moon all the way back here to Earth. And again, direct to Earth, you're going to see fairly low bandwidth, but even with these satellite relays, which are mentioned here on the site, you still need capable ground station hardware here on Earth to make this a reality. And there are certain bands on Earth that simply don't provide us the bandwidth we would like for large-scale operations on the lunar surface. They're great for 1 or 2 missions at a time, and that's fantastic. But what I think everyone on this panel here is moving towards is a sustainable presence on the lunar surface, which will mean hundreds of robotic systems operating at the same time. And we simply don't have that ground station capability here on Earth yet. I think we can move in that direction and move there fairly quickly, but we do need an improvement. And then satellite relays in cislunar space, again, just enabling that higher bandwidth communication. And then lastly, the improved transportation layer to the moon. So there are amazing companies like Intuitive Machines and other CLIPS providers that are getting that transportation layer in place. Of course, I think everyone has seen SpaceX's human landing system contracts, which was quite a sizable contract, and they actually just got a follow-on as well. So it's being put in place. But what we need to start doing is driving that cost down so we can send more material at a more sustainable way, right? Once you lower the price of accessing the market, then you can start bringing more companies, closing more business cases, and making things a more sustainable. You can start making the economy more sustainable from the aspect that you have more people involved and more diversified business cases. So that's all I had for my presentation. Thank you very much for taking the time to listen. And just to echo Derek's sentiment, it's certainly, sorry, let me stop sharing. It's certainly a pleasure to be here with the rest of these panelists. We're quite excited to see the international push towards making smart mobility to enable that kind of sustainable presence in cislunar space.
Thank you very much, Justin. It's very pertinent and very variety of the ideas. Thank you very much. So before the discussion, I'd like to take the some question from audience. I have maybe two, and the first one is from Nico-san, and the question to Faizan. The question is it planned to assembly the vehicles on lunar surface, or how especially the large vehicles shall be delivered to the moon?
Yeah, so
Faizan?
yeah, I
Yes.
can answer that question. When we look at these mission architectures, we sort of look at both possibilities of being able to send fully integrated vehicles onto the lunar surface. But certainly when we look at that mobility platform that I was showing, the idea is to have a payload deck which has interchangeable interchangeable interfaces, so that various pieces of components can be placed onto these payload decks. So we're looking at both variants of the mission architectures. One where the mobility platform and the associated pressurized modules or payloads go together on a single launch. But we'd look at the vehicles being designed with these interchangeable interfaces, so that you could send them separately and have the assembly done on the lunar surface as well.
Okay, thank you very much for your answer. And the next one is from Shinichiro Narita. So he has two questions. So the first one is the in-situ materials view. So, and the second one is heat supply view for the lunar night or permanent shadow area. Is there any answer from the participants? Justin, or do you have any view for the in-situ materials questions?
Absolutely. Yeah, I'm happy to answer the question. In-situ material, I think, is going to be quite exciting. And, I think certainly when you start looking at the materials available on the lunar surface, not only commercially, what can they do and what can they apply to the lunar surface economy, which I think is going to be quite important, because you do have hydrogen, solar wind implanted hydrogen, and then you have oxygen on the lunar surface. The moon is actually 45% by mass oxygen, which is it's a surprisingly high number. And then so you can not only utilize that for technology such as fuel cells, but you can utilize that for life support systems, and then refueling rockets to come back here to Earth, whether it's the SpaceX human landing system, whether it's Blue Origin's Blue Moon, or whatever landers it may be. One thing that you do mention in your question is lunar blocks and lunar concrete. And this is actually a pretty interesting topic of conversation. I could talk about this for quite a while, actually, but I'll keep my answer short. The lunar block and lunar concrete, I think, is perfectly placed, especially when we start building out towards that vision, similar to what Mitsubishi had presented, that large-scale habitat infrastructure. If you can start utilizing that lunar regolith, which is actually a very good radiation protectant on the outside of your habitats, and do that with lunar mobilities, the smart mobility, I think that's an excellent use case for early in situ resource utilization. Just to talk about one more use case is with the actually with our first planetary heritage at Lunar Outpost, it's an instrument called MOXIE. What we do is take CO2 out of the Martian atmosphere, running it over a reverse fuel cell process at around 800 degrees Celsius, and it turns it into oxygen and carbon monoxide on the other side. NASA has actually funded some research into fuel cell technologies to continue that type of research on the lunar surface. So basically getting pure oxygen out on the moon. And I do think those solar wind implanted volatiles, your oxygen, are going to be early use cases just based off of the technology that's needed. But as we start building out the supply chain of lunar materials that we can utilize, those lunar blocks, the lunar concrete to build on the lunar surface, not only the launch and landing pads, but the roads, the habitats, I think that's absolutely well placed. I think we'll head there. But certainly in the medium term, utilizing the materials on the moon to build craft out in cislunar space. So whether you're looking at your iron, your titanium, your platinum group metals, there's a lot of materials there that can be utilized in that broader cislunar market.
Okay, thank you. So I think the last question is from Nico again, and also to Justin again. Is it also your plan to recycle old non-operating robotic system parts to support the repair hubs, for example?
Excellent question again, Nico. It's absolutely critical. I think we utilize materials that are already in place on the lunar surface. And so while we start thinking about scaling robotic systems, there are parts of the rover that simply don't last as long as other parts of rovers. And that's just simply because a lot of the internal electronics will be protected. They don't have to deal with the dust ingress. They don't have to deal with the wear and tear of, the daily harsh realities of the external, that the external of the rover do, whether it's the extreme temperatures, whether it's the lunar regolith, or what have you. So certainly I think there are certain parts that are primed for being reutilized on the lunar surface. What you reutilize them for, I think, is the real question. Do you just take the brain out of one rover and put it in another rover when the drivetrain system eventually fails after a decade? Or do you start becoming a bit more strategic and start actually recycling the materials of the full rovers? It's not something that I think the broader cislunar market has figured out yet, but I do think the question is well placed, and we should push towards recycling spacecraft parts on the lunar surface and utilizing them in repair hubs or utilizing them in other robotic systems.
Thank you. Thank you very much. So I think that's all for the questions from the audience. And so then I'd like to discuss a little bit about the ideas from the panelists. So I found that I observed that the almost all the panelists talked about their power plant. So I believe that the power plant is very essential as an infrastructure for the mobilities. And also the many panelists talked about the communication relay for the to support the mobility operations. I think it's a very reasonable idea, and actually the many space agencies are research or developing the moon orbiter relay satellites for the communication. So I think the many people are all the related people is working kind of together. But I'm really bit curious that no one talks about navigation support, like GPS support around the Earth. So I'd like to ask the panelists: do you need such a navigation system like GPS, or do you don't need? So I'd like to ask the Derek from Lockheed Martin. What do you think?
So there's actually I mentioned that we're building, a couple of times we're building the LMV on our own nickel. there's actually 3 systems that are part of it. There's one, the LMV, 2, it's lander, which is based upon our Mars InSight lander, and 3 is a system called Parsec, which is our communications and navigation system, which will be launched in I think it's late 24, early 25 timeframe, and that provides both comm relay as well as PNT. As we've been designing the autonomy system doesn't depend on having GPS, but GPS provides or increases the efficiency of it to be able to enable us to be able to have greater accuracy in where we're at and optimized trajectories rather than just hazard and obstacle avoidance. So that was an excellent question because it's I would say it's a key enabler to be able to increase the efficiency of the vehicles, and really along with things like surface IoT, Internet of Things, really enables the sort of connected infrastructure. That helps.
I can also chime in on this question. So one of the things that that you see when you look at the autonomy on terrestrial vehicles, let's say a Tesla's autopilot, these platforms on Earth are using all kinds of support from GPS, the infrastructure that's already on the roads, like the lane markings, the road themselves, and this is something that you don't see in these unstructured environments on the Moon and Mars right now. So incorporating the elements like GPS or other cues onto the lunar surface can actually greatly extend your ability to perform autonomous operations on these moons. These are key technologies that while today we have close solutions to be able to operate the vehicles in these environments, in these unstructured environments, as you start bringing in structure through GPS, you really increase the efficiency, you increase the speed at which these vehicles can go through these environments.
Thank you. Japanese colleagues, do you have any comments?
Yeah, Yamaguchi speaking. I think it is better to have navigation to make sure where we are. So it is better, but I'm not sure when it is available or continuously usable or not. That is a key important point, I think. So that's all.
Yeah, I think that's a good point. Thank you very much. So any other topics to be discussed today? So we are running late. So okay, thank you very much. Then I'd like to summarize our discussion. Our colleagues summarize your discussion in real time. So can you see?
Naoki-san, can you hear me? because we have lost your voice. Dear participants, have you heard me?
Yeah.
Yes.
So probably there is a problem on the Japanese side. It's a very important point when Naoki-san has presented his findings. We unfortunately lost, I think, both video and sound. So maybe to save the situation, I can present some thoughts on my side, if you allow. Okay. Hello. Can you hear me?
Yes, yes, we can
Yes.
hear you.
Great. So anyway, the program assumes that in the end I give my summary, and it's exactly what I'm trying to do now. I think one can say that we achieved the goal of the event by showcasing the automobile industry's capabilities and opportunities of cooperation with space industry in the context of the moon exploration and utilization. We have met companies with really wide and very impressive range of vision, as well as diverse activities to implement this vision, who express their views on what one can expect in the years and decades to come and what is needed to advance in this direction. We have made a special emphasis on the business niches for automobile industry in the nascent moon market and the added value they bring to the traditional space stakeholders. I can tell you that today's elaborations will be useful inputs for the MVA architecture working group in the context of what we call OASIS 2045 concept development, where surface transportation plays a key role, of course. And by the way, all of you are invited to join the group as experts and to make your valuable contributions. Generally speaking, we will be more than happy to keep contact with you and to consider different options for our cooperation. I mean, MVA on one side and your respective companies on the other side. We are getting regularly different requests as to the possibility to participate in different missions. And who knows, maybe we can broker some situations where our MBA members or someone who knocks in our door could be a part of your respective missions, your respective payloads. So the elaborations we made today will be also useful for the Lunar Commerce and Economics Working Group, because we don't stop with our Lunar Commerce Portfolio version 1. We are starting already now to prepare the second version of the document. And by the way, I remind to everybody in attendance that the recently disclosed first version is available on the MVA website. Yes, now the event is almost over, but in my view, it's just the beginning for those interested in what has been presented and discussed today. So I invite everyone to contact the participants via MVA, for example, with your ideas and possibly proposals on cooperation. The full video of the event will be available soon on our website, so you may wish to revisit it or to recommend it to your colleagues and friends. We at MVA are committed to continue moving the needle, so to say, and organize new events related to other fields of the moon market. And the suggestions of those in attendance on a possible topic for our fourth event of this series are more than welcome. In general, I invite you to regularly visit our website for the latest developments and the announcements by MVA. For example, in the coming days, you will see a call related to the existing vacancies for the MVA national and regional coordinator positions, and many other useful information. Finally, let me send my words of gratitude, first of all, to our co-organizers, JAXA, Naoki-san, Yamasaki-san, arigato. I would like to send great thanks to our speakers for your participation and very stimulating presentations and discussion. My big thank goes to Shima Suresh, Moon Markets Development Coordinator Support, and to Glavki Antonio, Management Support, who hosted our today's meeting. Yes?
Sorry, this is Sato. My computer suddenly shut down.
Yes, we realize this.
Very sorry.
So I have made my conclusions already. I'm pleased to pass the floor to you now, Naoki-san, please.
No. Thank you very much. So also thank you to the all participants and all panelists. So it was very, very nice discussion, and I'm looking forward to see in future about any collaboration or any discussion. But thank you anyway.
So again, thank you all, and see you next time. We will keep in touch. All the best to all of you.
Thank you. Have a good holidays.
Thank you.
Bye-bye.
Bye.